Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about how to perform market basket analysis using R. Even before I proceed to demonstrate how to perform market basket analysis using R, may I request you to subscribe to my channel, also like and share my videos. Let's begin by asking a simple question. What exactly do we mean by market basket analysis? Market basket analysis is a type of association rule mining, which involves identifying patterns and relationships between data sets. The analysis identifies which products are often bought together and how frequently. The second point is, what are the key metrics that we need to look for when we conduct market basket analysis? The key metrics used in market basket analysis include support, confidence, and lift. Support refers to the frequency at which a product is purchased. Confidence is the probability that a product B is purchased given that a product A is purchased. Lift measures the strength of association between two products. Now, what are some of the uses of market basket analysis? Market basket analysis can be used for various purposes, such as cross-selling, upselling, inventory management, product bundling, and pricing optimization. Fourthly, let's look at some of the data sources. What could be the potential data sources for market basket analysis? The data required for market basket analysis comes from transactional data such as point of sale systems, customer databases, and e-commerce platforms. This data must be cleaned, processed, and transformed before it can be used for analysis. What are some of the important tools and techniques for market basket analysis? Market basket analysis can be performed using various tools and techniques such as Apriori algorithm, the FP growth algorithm, the ECLAT algorithm, and association rule mining algorithms. These tools and techniques can help businesses to discover meaningful relationships between products and ultimately make informed decisions to improve sales and customer satisfaction. As you can see here, I'm using R to execute the Apriori algorithm. Apriori is one of the algorithms, the most popular algorithms to execute a market basket analysis model. Let's begin by installing the necessary packages. There are three packages which I'll be using in this particular video. The first one is what is called as A-Rules package. As you can see here, I'm using a simple command, library of A-Rules. I've already installed the package A-Rules, and therefore I'm only calling the library here. In case you are installing the A-Rules package for the very first time, you might want to use the command install.packages of A-Rules within double quotes. Then we go ahead and hit the enter button. What this does is it installs the library A-Rules. Next, let's call the library A-Rules Viz. You can see here, this is the library A-Rules Viz. In the third step, what I'm going to do is I'm going to call a library which is called as color space. We go ahead and execute the color space. Now, what exactly is the color space? The R package color space provides a flexible toolbox for selecting individual colors, for manipulating these colors and employing them in statistical graphs and data visualization. Now that we have successfully installed the libraries and called each of these packages, the next step would be to perform EDA or exploratory data analysis. Even before I proceed to do that, let me increase the font size. I can go to Edit, GUI preferences. The size can be 20. I'll just click on OK. Now, what I'm going to do is I'm going to load a data set, which is called as the groceries data set. Now, this is already inbuilt and it comes by default when you install the A-Rules package. Let me load this particular data set. In the next line, what I'm going to do is I'm going to assign groceries to an object which is called as transactions object. We go ahead and quickly hit the enter button. We have created a new object at this stage, which is called as the transactions object. As part of the descriptive statistics, what I'm now going to do is summarize the data set, which is called as transactions data set. I'll be using the summary command to summarize the data set transactions. You can see here, R prints a lot of output. Let's look at each of these output one by one. You can see here, this is the output of the summary command. What R says is that there are 9,835 rows, which means that we have a healthy sample size. Approximately 10,000 records is what we have in this particular data set. How many products do we have? We have 169 columns. Each column represents a particular product. You can look at the density here. The density would be 2%. In fact, it is 2.6%. What does this mean? If you take the product of 9,835, multiply it by 169, you'll be getting a big number. Out of these many cells in the Excel, you can safely assume that 2.5% of these cells will be populated. Why is this so? If you're a typical customer and there are thousands and thousands of products in a Big Bazaar or in Reliance Fresh, you may not be purchasing every product. You may buy 10 items. In a retail outlet, you may have 1,000 products, and let's say you buy only 10 products, which means that the remaining 9,990 cell values will be blank. And therefore, this results in huge sparsity. If the density is 2.6%, it automatically means that roughly 97% of the cells are sparse. So you have a huge sparse matrix. Now, this gives us a high-level perspective about the data set that we are dealing with. There are roughly 10,000 rows, 169 products, and the density is 2.6%, or in other words, 100% minus 2.5% would roughly be 97.5%. Therefore, the sparsity here would be the sparsity here would be 97.5%. Ideally speaking, for a good data set, we would like to have a high value of density. Typically, if the density is above 10%, it's a good indication. Let's make a move on. You can see here now, R says the most frequent items. As the name itself suggests, this is indicating the most popular items. Whole milk, 2,513 is the frequency for whole milk. If you were to take a simple ratio of 2,500 and 10,000, I'm rounding off 9,835 to 10,000 for understanding purpose. 2,500 divided by 10,000 would be roughly 1/4, which means out of every 4 transactions that you see, one of the transactions involves whole milk, which is a substantial number. Then let's make a move on to other vegetables. This is the second most popular item. The first most popular item is whole milk. The second most popular item is other vegetables. Roughly 1,903. If you round it off, it will be 2,000. 2,000 divided by 10,000 would be 1/5, which means out of every 5 transactions, you can expect one of the transactions to involve other vegetables. The third most popular item, which is getting purchased would be rolls and buns. The fourth most popular item would be soda. Then you have yogurt and other products. So this is a high-level perspective about some of the most popular items. Which are the most popular items? You can say whole milk, other vegetables, rolls or buns. Then you have soda and yogurt. Let me scroll down. Here you can see the length distribution, the element length distribution. There are 2,159 transactions wherein customers have purchased only one product. This is a good chance for us to cross-sell items. There are 1,643 transactions wherein customers have purchased two items. Similarly, there are 1,299 transactions wherein customers have purchased three items only. As you move towards the right side, you can see more and more number of items. If you look at the last record, here it says 30. How many customers have purchased? In fact, it is 32. The maximum number of items that have been purchased would be 32. There is one customer who has purchased 32 items. Maybe he's shopping for the entire month and therefore he has made a bulk purchase of 32 items. It is expected more number of products are bought by fewer number of people, and therefore the frequency here is 1. So this gives us a high-level summary of what is going on in the data set. You can also look at certain other values like median transaction, the mean transaction, and some other description. Let's now proceed to the next piece of analysis. In the next segment, we'll be looking at the number of rows. The simple command that will help us look at the number of rows would be nrow. You can use the command nrow and pass the transaction object. You can see here 9,835 transactions is what we have observed in this particular data set. With this high-level perspective about the descriptive statistics about the data set, it is now time for us to move to the next stage of analysis. The next stage of analysis would be data visualization. How do we visualize the product associations, the most popular products, so on and so forth? At this stage, I'll be using a very simple command, which is called as item frequency plot. Let me clear the screen. Now we'll be doing a bit of data visualization so that we can understand at a very high level what is going on as far as the purchase of these products are concerned. This is a very simple command which is called as item frequency plot. The first argument here would be the transaction data set. The support value, the minimum support value that I'm specifying is 10% here. You can specify any other number. I'm using a number of 10%. We can experiment with either 5% or 15%. This is entirely under your control. Let me go ahead and execute this particular command. What you're seeing at this stage, once you execute this particular command, would be a bar chart. As you can clearly see here, in the x-axis, we have different products like tropical fruit, root vegetables, other vegetables. In the y-axis, what you have is the item frequency. We have the relative frequency distribution. The most popular item here seems to be whole milk. It is appearing in 25% of the transactions. The second most important product here would be other vegetables, which is appearing in 20% of the transactions. The third most important product here would be rolls or buns. As you can see here, since the minimum threshold for support is 10%, the length of the bar, almost every bar has a minimum value of 10%. You don't see one single bar which is less than 10%. This is a simple frequency distribution plot that we have seen. Now, is there a different way of looking at the same graph? what I'm going to do is I'm going to recall the same command, that is the item frequency plot. And here I'm going to specify an additional command, which is called as color. Usually if you specify 1, it stands for black. I'm going to use color equals 2. Let me go ahead and hit the enter button. This is the output of the item frequency plot. What you're seeing here is a very, very striking chart. This is very useful because you can take this and create a PowerPoint presentation out of this particular graph. This tells me the 8 most important products or the 8 most popular products. Since I have already interpreted this in the earlier command, I'll not again interpret this. Let me close this particular chart. Now, what you can see here is I've specified color equals 2. You can also go ahead and specify color equals 3 or 4 or 5, 6, 7, any of these things. Let me experiment with color equals 3. You can see here, you're getting the bars which are green in color. If you do not want a chart which is green in color, perhaps you can specify 4 here. You can see a blue color bar chart. Let me experiment with 5. You are getting a different color here again. One other thing that you can do is, apart from specifying the color argument, you can flip the chart. That is, you can create a horizontal bar chart instead of looking at a vertical bar chart. How do you do this? You can specify horizontal equals true. You can see here, this is how the horizontal bar chart would look like. I'm happier with the red color. So let me just close this particular output and specify color as 2. This is visually more appealing. This clearly tells us which are the most important products in the retail outlet. Now, with this bit of a background, what we would like to do is we'd like to experiment with different variations of the item frequency plot. Let me now proceed to reduce the support value. As you can clearly see here, earlier I was pretty strict with the support value of 10%. If you want to display a bar chart with more number of products, you can reduce the support to 5%. Now, since you have reduced the support value to a lower number, you can expect more number of products. I'm going to use color equals 2 and horizontal equals true again. Let me go ahead and hit the enter button. As you can see here, this is the new bar chart that we have. What does this tell me? You can see here there are a lot of products, at least 20 different products are being displayed. And along the x-axis, you can see the relative frequency distribution. As before, we can see this is the longest bar and this corresponds to whole milk. That is the most important product. Next to whole milk, you have other vegetables, and you also have other important products like rolls or buns and soda. So this is how the frequency distribution chart would look like. At this stage, what I'll be doing is I will be proceeding to display the top 10 items. In fact, the top 20 items. Earlier, we were looking at the relative frequency distribution. Now, I'll be looking at, instead of the relative frequency distribution, the absolute frequency distribution. The command would be more or less the same. That is, I'm still using the item frequency plot. I'm passing the transactions file. Top n equals 20. Now, this is entirely under your control. Instead of 20, you can change it to 10 or 15 or the top 5 items. Let me go ahead and hit the enter button. You can see here, this represents the top 20 items, which is arranged in descending order. Starting with whole milk, other vegetables, rolls and buns. And at the other extreme, you have domestic eggs, brown bread, you have whipped or sour cream, so on and so forth. Now, once you're through with the frequency distribution, what is the next stage of analysis? The next stage of analysis would be, let me quickly show you the next stage of analysis. We will be looking at the top 10 items. Earlier, we looked at top 20 items. We can just change this to top 10 items. Here, there is an additional argument which says type equals absolute, because we are looking at the absolute frequency distribution, not the relative distribution. Let me go ahead and execute this particular command. You can see here, this would give you the absolute frequency distribution. We are familiar with this particular graph, so I'll not again explain this particular graph. Let's look at one more variation of the item frequency plot. In fact, what I would do at this stage is I would make a move on to the Apriori algorithm. So far, what we were doing would be the EDA or the exploratory data analysis. Now we'll be actually running the Apriori algorithm. There's a very simple command which we can use to run the Apriori algorithm. You can see here, what I'm doing here is creating rules. The command that we will be using is the Apriori command. This is the Apriori command that we'll be using. This command will be run on the groceries dataset. There are certain parameters that we will be specifying called as support and confidence. Again, these numbers are very subjective. It varies from business to business. You can feel free to experiment with these numbers. Let me go ahead and run the Apriori algorithm. R prints a lot of output. Not all of this would be relevant in this particular video. Let me quickly draw your attention to a very important number here, 224 rules. What is the output of running the Apriori algorithm? What R says is, after running the Apriori algorithm, we have extracted 224 rules. What are these 224 rules? We'll be seeing in a bit. You can simply type summary of rules. This will give us an opportunity to take a peek into the rules that we have extracted. So this is the output of summary of rules. You can see here, out of the 224 rules, there are 111 rules which features two items, that is product A and product B. There are 113 rules which have been extracted for 3 products. When you add up 111 and 113, you'll be getting 224 rules. On an average, a customer would be buying 3 items in the grocery dataset. You have other important quality measures like support, confidence, coverage, and lift. What is the average value for support? It is 1.6. Then you have the mean value for confidence, which is 37%. For coverage, you have 4.5%. And then for lift, the mean value is greater than 1. It is 1.9, which is a good sign. Further, so far, we have not displayed the important rules. The important thing in market basket analysis would be to display the rules of a priori algorithm. Let me go ahead and display the rules. Firstly, let me clear the screen so that it's a lot easier for us to display the rules. To display the top 5 rules, though we have extracted 224 rules, it's a bit difficult to look at each of these 224 rules. Instead of showing you all the 224 rules, what I'll be doing is I will be showing you only the top 5 rules. I'll be running the inspect command, and here I'm specifying only the top 5 rules. Let me go ahead and hit the enter button. Once I hit the enter button, you can see here R prints the output of the a priori algorithm. Let me go over each of these things step by step. You have LHS, which stands for left-hand side, and then you have the RHS. What is the difference between LHS and RHS? In the LHS, what you have is bread and yogurt. In the RHS, you have whole milk. This has to be interpreted as if-then condition. If something holds good, then it triggers a response. As an example, if you study hard in an examination, then you can expect to get good results. If it rains outside, then you'll get wet. So there's a if-then connection amongst the rules. So if a customer buys bread and yogurt, you can expect him to buy whole milk. Similarly, if a customer buys items in the LHS, namely citrus fruit and root vegetables, then you can expect him to buy other vegetables. These are some of the rules. Let me look at the third rule. If a customer buys tropical fruit and root vegetables, it implies he can buy other vegetables. The fourth important rule is curd and yogurt. If a customer buys curd and yogurt, then you can expect him to buy whole milk. Last but not the least, if a customer buys other vegetables and curd, you can expect him to buy whole milk. Now, why is this useful? This is very, very useful because it helps you cross-sell. If you have a simple question in mind as to whom should I sell whole milk to, this table is very, very useful. It clearly says that sell whole milk to a customer who has already purchased butter and yogurt. Similarly, you can also sell whole milk to a customer who has purchased curd and yogurt. You can also make an effort of selling whole milk to those customers who have purchased other vegetables and curd. You can see here how cross-selling can be easily done once you perform association rule mining. There are certain important quality measures that we need to pay attention to. What is the confidence with which we can say that this rule can be implemented? You can see here, there are a lot of measures here, like the support measure, confidence measure, then you have coverage, lift, and count. Let's look at this one by one. Let's begin with the support measure. The support is 0.9%, which is less than 1%. What does this mean? Support, remember, indicates how popular a product is of all the product transactions. I repeat, support indicates how popular a product of all the product transactions is. To calculate support, we can use a simple formula: number of transactions involving a particular product divided by the total number of transactions. Out of the 10,000 transactions, 1% of the people have purchased butter and yogurt. Similarly, here you can see 0.01, which means 1% of the transactions involve purchase of citrus fruit and root vegetables. There's another important quality measure, which is called as the confidence measure. What is confidence? Confidence represents the likelihood of purchasing both the products A and B. When we say confidence, it's the number of transactions that include both A and B divided by the number of transactions which include only product A. As you can clearly see here, we have a number of 63%. What does this mean? It simply means that out of those customers who purchased butter and yogurt, 63% of customers purchased whole milk. Similarly, how do we interpret 58%? Out of those customers who purchased citrus fruit and root vegetables, 58% of customers purchased other vegetables. Support and confidence are very, very useful when you evaluate the quality of the rule. Next, let's move on to what is called as coverage. Coverage is not widely used when you're assessing the performance of a market basket analysis rule. Coverage is also called as cover or the LHS support. It indicates the support for the LHS. This is the support of the LHS of the rule. It represents a measure of how often a rule can be applied. Next, you have a very, very important measure, which is called as the lift measure. Now, how do we interpret the lift measure? There are many ways in which you can interpret the lift measure. Lift is a measure that will help the store managers to decide the product placement on the aisle. I repeat, lift is a measure which will help the store managers to decide the product placement on the aisle. Now, the lift value can be 1. What does this mean? If the lift is exactly 1, it means that the products A and B are independent of each other. If the lift is greater than 1, it means that the product A and B are positively correlated, which means that purchase of one product will trigger purchase of the other product. If the lift is less than 1, it means that the products A and B are negatively correlated. Remember, lift indicates the preference to buy the items in the RHS, given that a customer has already bought items in the LHS. I repeat, lift indicates the preference to buy the items in the RHS, given that a customer has already bought items in the LHS. Let me interpret 2.5 here. How do we interpret 2.5? In the context of this particular example, in the LHS, we have butter and yogurt. Let's consider a hypothetical customer, John, and another hypothetical customer, Matthew. Let us presume for the sake of discussion that John has purchased butter and yogurt, while Matthew has not purchased butter and yogurt. I repeat, John has purchased butter and yogurt. Matthew has not purchased butter and yogurt. The question is, should I cross-sell whole milk to John or Matthew? Clearly, when you look at the lift value of 2.5, what it suggests is, it says, if you were to cross-sell whole milk to John, who has already purchased butter and yogurt, he is 2.5 times more likely to respond to your offer of whole milk as compared to a customer like Matthew, who has not purchased butter and yogurt. Now, what this does is, it tells you the preference to buy the items in the RHS, given that a customer has already bought the items in the LHS. Instead of randomly targeting a customer, this indicates it is better to target a customer who has purchased items in the LHS. Now, what is a typical cutoff that we need to look at? As far as lift is concerned, always focus on high values of lift. Typically, if the lift value is greater than 1, we tend to take it seriously. On the other hand, if the lift value is less than 1, we tend to ignore it. One important point to note here is that when we run an Apriori algorithm tries to find out the associations for every product. On the other hand, the business demand might not be to look at product affinity for each and every product in the store. The business may be specifically interested in specific products. It may be interested in particular products like product A, B, and C. So instead of studying all 224 rules, we would like to limit our analysis to only those products which the business is interested in. How do we limit the analysis for only those products which the business is interested in? This is where we would like to modify the code. Remember, just now we have inspected the top 5 rules. Now the goal would be to focus our analysis on beverages. This analysis has a simple aim to see what makes people buy milk. What products to be exact. To do so, we should choose a subset of rules that has only whole milk or soda in the right hand side of a rule. Let me carry out this analysis. Let me clear the screen. As you can see here in the code, we are specifically interested in studying milk as a product. Therefore, I'm extracting a subset. Here in the subset parameter, I'm limiting to only those products which have whole milk. You can see RHS percentage in percentage is whole milk. We'll be looking at the rules by confidence. This will extract all those rules which have whole milk in the right hand side, and it will create an object called as milk.rules. To study this further, what we will be doing is we can quickly inspect the top rules for milk. If you want to study whether there's a statistical significance for the rules that we have extracted for milk as a product, what is it that we need to do? We can use the command is.significant of milk.rules and specify the dataset name. Here you can see we have more than 70 rules that have been extracted for milk. For many of these rules, R displays true, which means it is statistically significant. However, if you look at the last 3 rules, it says false, which means that the last 3 rules are not statistically significant. Only those rules which are statistically significant we tend to take seriously. However, those rules which are statistically insignificant, we can ignore. Let us inspect some of the rules for milk as a product. I'm going to run the command inspect of milk.rules. You can see here there are almost 85 rules, and the RHS is now fixed as only whole milk. You can see here there are 85 other products with which you can sell whole milk. Butter, yogurt goes well with whole milk. Similarly, curd and yogurt again can be cross-sold. You can, or rather, let me rephrase this. You can cross-sell whole milk to those customers who have already purchased curd and yogurt. There's a product association also that is observed between other vegetables, curd and whole milk. Now, out of these 85 rules, you will have to look at the value of the lift. Higher the value of the lift, more is the correlation. Lower the value of the lift, weaker is the correlation. If you scroll down, you can see the lift value gradually reduces. In fact, it becomes smaller and smaller. What we observed was that the last 3 rules was statistically insignificant. So bottled beer and whole milk, this is statistically insignificant. Salty snack with whole milk, again, this is statistically insignificant. Sausage, rolls or buns and whole milk, again, this is statistically insignificant. So what this does is we will be able to specifically pitch in whole milk to those people who have already bought any of the products in the LHS. Let's now proceed to do the same thing for Coke. Let me clear the screen. As you can see here, I'm extracting a subset of rules This time, I'm specifying that the RHS must strictly have soda. We go ahead and click on enter. Now this will create a object which is called as coke.rules. Let me go ahead and inspect coke.rules. We can give the command as inspect of coke.rules. Here you can see the RHS is fixed as only soda. So we can cross-sell soda with those customers who have purchased either sausage or rolls and buns. You can also cross-sell soda with chocolate buyers, dessert buyers, bottled water buyers, sausage, so on and so forth. We might want to take a look at the lift. The fact that the lift value is greater than 1 is a good indication. What we have done at this stage is to extract rules only for Coke and whole milk. In the next stage, what I'd like to do is I'd like to study whether these rules that we have extracted for Coke is statistically significant or insignificant. Here you can see is.significant. This is the command that we will be using. As you can see here, for all the 6 rules are displayed true, which means that these 6 rules for Coke are statistically significant. We might want to plot the relationship between support, confidence, and lift for Coke. What I'm going to do at this stage is run the command plot only for Coke.rules. As you can see here, measure would be support, then we have confidence, and the shading will be based on lift. There are 6 rules. Will we go ahead and execute this? You can see here what R says is this is a scatter plot for 6 rules. In the y-axis, we have confidence. You can see the range for confidence from 0 all the way up to 0.5. Similarly, in the x-axis, we have support. The range for support is from 0 to 0.035. You can see some of these dots. There is a dot which represents one of the rules. How do we interpret this dot? You have to look at the legend here. You can see here the legend represents lift. Darker the red color, higher is the lift value. Lower the value of the lift is represented by lighter shades of lift value. So if you see dark red color, it means that the lift can go as high as 1.8. Light red colors correspond to a low lift value. The fact that we are seeing one dot here, it represents one particular rule which has a high value on the y-axis, which means the confidence is high, but the support is extremely low. You can clearly see the x-axis value is low and the lift value is very, very high. You're not able to see the other 5 dots because these 5 dots have a very low value of lift. So this is how a scatter plot can be used to study the interrelationship between support, confidence, and lift. I have done this for Coke. You can repeat the same example with respect to milk. What I'm going to do now is look at meat as a product. Earlier, you've seen that we have fixed the RHS as Coke or whole milk. This time, I'm going to tweak the rule. As you can clearly see here, this is the same condition that I'm giving, subset of rules, but the filter condition that I'm providing is subset should be in such a way that the LHS, please observe, this is the LHS, not the RHS. We are looking at those customers who have purchased only beef or sausage or chicken. We are fixing the LHS this time. What this does is it would extract the meat rules. Let's further inspect some of the meat rules. Inspect of meat.rules. As you can clearly see here, this command would extract different rules for meat as a product. In the LHS, you have beef and other vegetables, and in the RHS, you have whole milk. Please observe consistently in LHS, we are limiting the product to only beef or other vegetables. You either have beef or chicken or some other product which we have specified here in the subset. This will indicate the next best buy. What this means is that given that a customer has purchased beef, you can expect him to buy whole milk. Similarly, if a person has purchased beef and whole milk, you can also expect him to buy other vegetables. Chicken buyers can be expected to buy other vegetables as well. So this is how we can refine the output of a priori to focus our analysis on only specific products rather than look at each and every product. What is the next thing that we will be doing? The next thing is to construct certain interactive charts. I'll be again making use of a scatter plot. This is the first chart that I'll be doing. The plot command can be used to create a simple scatter plot. Now, once you type this particular command, plot of coke.rules, method equals graph, and interactive equals false. Let's see what happens with this. If we go ahead and execute this particular command, you can see here, there are quite a few products like bottled water, chocolate, dessert, soda, fruit, or vegetable juice. The legend here says the distribution of lift. Darker values of lift represent high values of lift. Similarly, the size of the bubble represent the value of the support. Bigger the size of the bubble, larger is the value of the support. Smaller the size of the bubble, weaker is the support. But this graph is not very conclusive. Is there a better way in which we can interpret the graph? To interpret this chart in a better way, what I'm going to do is I'm going to change the parameter value from interactive equals false to true. I don't think I'll be modifying other parameters. Let me go ahead and execute this particular command. You can see here, this is how the interactive chart would appear. This is the output of the interactive chart. What you're seeing here is right at the center, we have soda. This is the product of our interest. Then you're able to see certain products in the periphery like bottled water, dessert, fruit or vegetable juice, rolls or buns, and sausage. The size of the circle represents the size of the support. Bigger circle indicates that the customer is more likely to buy the two of these items. When you see a small circle, it indicates that the support is very weak. Darker the shade of the red color indicates high lift value. Lighter shades of red indicate low lift value. Also, please observe the direction of the arrow. This is a very interesting representation. The arrow points to the direction of a possible basket rule. For example, dessert buyers can be expected to buy soda. Similarly, people who buy fruit or vegetable juice can be expected to buy soda. Next, people who buy rolls or buns can be expected to buy soda. The same argument can be made for sausage, chocolate, and bottled water. Please observe the size of the circle. As I already told, the size of the circle basically indicates the size of the support, and the darker the red color indicates high lift value, lighter the red color indicates low lift value. Is there a better way of visualizing this? Yes, you can go to layout here. And the third option from the top would be Fractoman Rain Gold. Here, this is a way of arranging the layout. You have default number of iterations as 500. The start temperature value, you can experiment with this. I can go ahead and give this as OK. You can see here the circles spread out. This is very useful when you have a lot of rules. Let me close this and come back to the code. We've seen one interesting visualization. Let me now do the same thing, but for yogurt. You can see here, everything would be the same, but as far as the LHS is concerned, I'm limiting the product as yogurt. I'm sorting by confidence as well. Let me go ahead and execute rules for yogurt as a product. The next step would be to plot the yogurt rules. You can see here, there are a lot of products here. Unlike the earlier chart, wherein you merely had 6 or 7 rules, but here for yogurt, you have many different products. Let's put more life into this by turning the interactive parameter as true. Interactive rather than false. I'm going to make this as true and rerun the entire analysis. You can see here, this is how the graph would look like. It is crowded because you have a lot of products. Again, I can change the layout by going to Layout, Fractoman, Rain Gold, and then click on OK. The direction of the arrow is very, very important because it points to the direction of the possible basket rule. We have yogurt and whole milk. There are a lot of products like whipped sour cream. You have rolls or buns, other vegetables, tropical fruit, root vegetables, soda, circus fruit. Sorry, my apologies. It's citrus fruit. This is citrus fruit. Then you have vegetable juice, yes. Then you have butter, bottled water, which are associated with whole milk and yogurt. Let me now come back to a few other visualizations. We'll now proceed to look at another interesting quality measure, which is called as the Jaccard measure. Just as you have the Euclid's distance measure or the Mahalanobis' distance measure, you have a very important measure which is called as the Jaccard measure. Let's study the Jaccard measure to find out the similar items. Higher the similarity indicates products which are co-occurring. Lower the similarity value indicates products which are dissimilar. We're going to quickly study the similarity metrics for the products. You can see here, this is the command that we can use to study the product similarity. Transactions of item frequency. The transaction must be greater than 0.1 in fact. Once I run this particular command, after this, I can construct a similarity matrix. So this is the command that we can look at to check out the dissimilarity between different products. If we go ahead and execute this particular command, you can see here R prints a lot of output here. Each of these numbers that you see will lie between 0 and 1. If the number is close to 1, it means that there is greater similarity. On the other hand, if the number is close to 0, it means that there is greater dissimilarity. When you look at the first column, this talks about the product association between tropical fruit and root vegetable. It is almost 89%. However, tropical fruit has a greater similarity with rolls or buns, bottled water, as well as soda. The highest similarity is with soda because the similarity value is 0.91. Greater the similarity value, greater is the chance that you'll find these two items in the same basket. You can expect a customer to buy soda as well as tropical fruit in his transaction. You have similarity values for other products as well, but I'll skip the similarity value for other products. Next, we will look at certain advanced graphics. As you can clearly see here, we are getting a graph in such a way that along the columns you have the different rules, but these rules are those rules wherein the LHS, for example, has whole milk or beef. So this is one of the rules wherein in the LHS we have whole milk or beef. Look at the RHS here. The RHS is represented along the row wherein we have root vegetables. So some of the products that could possibly go with the LHS are root vegetables, other vegetables, rolls or buns, soda, and whole milk. Here you have different items in the LHS like soda or sausage, you have chicken, beef, so on and so forth. You can look at the legend here. The blue color, darker the blue color represents high value of lift. In fact, lighter shades of blue color represent very low values of lift. The lift value can go as high as 3. We might want to take a look at each of these circles because they represent high values of lift. How do we interpret this? Given that a customer has purchased sausage, you can expect him to buy other vegetables, rolls or buns, soda, as well as whole milk. You can look at some of these smaller values, smaller circles. These smaller circles basically indicate low value of support. Bigger the circle size, higher the support. Lower circles indicate weaker is the support. Since market basket analysis is a very complex technique with many different rules, a good strategy to reduce the complexity would be through usage of graphs. Let's now proceed to create a few tree maps. Before a tree map, I could run a parallel coordinates plot. You can see here, plot of meet.rules method. Instead of grouped, I'm changing the value to parallel coordinates. Let me go ahead and execute this particular graph. This is the output of the parallel coordinates plot. It looks slightly difficult in the first view. Let me explain this. In the x-axis, you have items in the LHS, especially position 2 and position 1 represents items which a customer has purchased as far as the LHS is concerned. Here you have the RHS. The different products are listed in the y-axis. Now you see a thick red line here. What does this mean? It simply means that a customer who has purchased sausage can be expected to purchase rolls or buns. Similarly, a person who has purchased beef can be expected to buy chicken. A person who has purchased chicken can be expected to buy other vegetables. Now, there are certain light red color lines as well, which means that if a person buys whole milk and beef, then there's a good chance that he buys root vegetables. You can experiment with parallel coordinates for different products. Here, the parallel coordinate plots 19 different rules. Now that we have seen how a parallel coordinate plot works, let us now go ahead and create a tree map. To create the tree map, we would first need to use a library which is called as the dplyr library. In case you have not installed this, it would be better to install this particular package and then call the library. Once we have called the library tree map, the next would be to group by level 1. You can see here, I'm creating an object which is called as occur1. I'm taking transactions at item info, feeding this into group by of level 1. I'm summarizing it by the number of transactions. The next thing that we will be doing would be to summarize based on level 2. I can repeat the same experiment as far as summarizing this based on level 3 is concerned. So these are the 3 objects that I've created: occurrence 1, occurrence 2, and occurrence 3. In the next stage, we'll be using these objects to create a tree map. To create a tree map, we have to use a function which is called as the Treemap function. As you can see here, I'm using the Treemap command. Let me go ahead and execute this particular graph. You can see here, this is the output of the tree map. This is a very interesting map. The tree map can be called as a hierarchy chart wherein there's a relationship between the parent and the child. It shows the parent-child relationship. You can see there's a big box for fresh products, which means that maximum number of purchases that the customers have made with respect to fresh products. People have bought a lot of items corresponding to fresh products. The second largest items that have been consumed would be non-food items, and thirdly, it would be snacks and candies. So larger the size of the rectangle, higher the purchase of that particular item. You can see here when it comes to detergent and perfumery, the size of the rectangle is very small, indicating that these items are not purchased as frequently as, let's say, fresh products. So this is giving us a 10,000 feet perspective about which are the items which are sold highly. What we can do at this stage would be to further dig and look at within fresh products, which are the items that are getting purchased. So if we have to study within fresh products, which are the items that are getting purchased, what you can do is you can again use the Treemap command, rerun the analysis. When we rerun the analysis, we will get another representation of the tree map. What you're seeing here is the distribution of different sub-products under fresh products. Within fresh product, you can see we can have cheese, dairy product, frozen food, shelf-stable dairy product, and then eggs. Larger the rectangle indicates higher is a transaction. So mostly you can see high transaction is seen with respect to products like cheese, frozen food, dairy products. You can also have shelf-stable dairy product. When you look at the distribution of non-food items, you can see the distribution is mostly dominated by non-food housekeeping products, then non-food kitchen products, then we have some other products as well. If you want to further do a deep dive and look at the distribution as far as level 3 is concerned, what you can do is you can again run a Treemap function. But as you can see here, I'm using the object occur3. Let me quickly show you the distribution of the Treemap. Now, this is how the output of the Treemap looks like. This is the third level of hierarchy as far as fresh products are concerned. Within fresh products, you have different items like cream, curd cheese, curd, dessert, so on and so forth. Similarly, for processed food, again, you see the distribution here like honey, mustard, sausage, so on. In fact, I stand corrected. It is not sausage. You can see this is sauces. So you have within processed food, the distribution of honey, mustard, oil, rice, salt, sauces, so on and so forth. So this is how you can look at Treemap for a parent-child relationship and the distribution of different items within each of the higher level of products. In this video, we have seen Apriori algorithm. We have looked at some of the advantages of Apriori algorithm. Further, we looked at the distribution of some of the important key performance measures like support, confidence, lift, coverage. We have also seen how to limit the output of Apriori for LHS and RHS. Then we moved on to look at certain visualization which are specific to Apriori algorithm. With this, I have come to the end of today's video. I request you to subscribe to my channel, also like and share my videos. Thank you very much for watching this particular video. Have a great day ahead.